So hi all, in today's class we are going to see about the steps of asynchronous sequential circuit. So there is totally 8 steps available in designing any asynchronous level circuit designing. So in this particular video we will be focusing on the first 3 steps over here. The first 3 over here will be first discussed in this step. The reason why I stated this thing is because in most of the university questions they will be asking from the third step. They will be giving, if you see the third step is your state diagram, they will be giving a state diagram just like this. 0 0, it is moving to another 0 1, it is moving to 1 0, like that. A kind of state diagram structure will be given. You want to design the sequential, asynchronous sequential circuit from the state diagram. These kind of things will be given. So I thought of doing this part in a separate video, and up to this part in a separate video. Okay. So for that understanding, today we are. So this is the total 8 steps. So first one is from a problem, try to get the initial state table, then try to reduce it, then try to get a state diagram from it, then draw the primitive table, implicit table, Mauser graph. Then get the Boolean expression, finally the logic diagram. So this is a step. We can move to the problem, then you will get a clear idea what is the actual usage of this particular steps. Okay, so this is our problem. So before going to in depth of the problem, try to read the problem once, or else I also will help you reading it out. Okay, so design an asynchronous sequential circuit that has 2 inputs. So make a solution like this. So we are going to provide a solution over here. That is 2 inputs, x2 and x1, and an output is it. So output is it. So to differentiate it, we are going to. So this is your output. This is your input. So this is your output and this is your input. Okay. Okay. We have differentiated it. So now x1, x2, and the output is set, and the output is okay. Then when x1 is equal to 0, so default we can mention it over here. When x1 is equal to 0, the output of z is 0. The output of z is 0. So when x1 is equal to 0, output is 0. It's given. Then the first change in x2 that occurs while x1 is 1. When x1 is 1, the first change, when it is happening, your output is 1. That's what is given. Is it to be 1? The output z will remain 1 until x1 returns to 0, which means whenever 0 is there, default you should put this answer. When x1 is 0, output is, that's it. No talk apart from it. When 0 means 0, that's it, no doubt. So this is the simple thing given. So little bit we can elaborate in this ideology, so we will get a better understanding. Okay, so for your understanding, what I am going to do is x2 is 1, x1 is 1, x1, and I am going to make it a tabulation like this. Okay, and in this tabulation I am going to start with 0 0. So from this concept, when x2 is 0, x1 is 0, what is your output? It's very simple. x1 is 0 means it is 0. So 0. Now x2 is 0, x1 is 1. What is your output? It's very simple. Once again, here 1, and see, this is not simple. The reason is x1 is 1. First change. What is the change is the previous state is previous value is of s2 is 0, but this value is also 0, which means there is no change. Here what is the condition? First change. There is no change, but x1 is 1. So you can't put 1, instead you can put 0. Now what I am doing is keeping x1 1, I am going to change x2 value, that is 1. So what happens? From here to here there is a change. So when change occurs and x1 is 1, your answer is 1. Now keeping 1 again, keeping this 1 again, from here to here there is no change, x1 is 1, so it is 0. Then keeping this 1 here, changing it to 0, from here to here there is a change, keeping on x1 as 1, you know that answer is 1. Step 1 is making an initial table. I want to make an initial table out of the given things. So what I am going to do is x2, x1 and z. So as you people know, 3 variables. Yeah. So from this itself we can get an idea. These two are input, and this is your output. That also we know. Now the problem is like the solution is like the x1, x2. There is 4 possible: 0, 0, 0, 1, 1, 0, 1, 1. So I am mentioning it over here: 0, 0, 0, 1. 1, 0, 1, 1. Yeah. And the output, for the same case, the output it shall be 0 or else 1. So for that particular reason, what I am going to do is the same tabulation, because your output can be 0 or else 1, 0 or else 1, 0 or else 1, 0 or else 1. Alright. So I am adding other possibilities for the given problem. These are the other possibilities. So in this problem, which and all will accept this one, we can check. So when x1 is 0, your output should be 0. When your x1 is 0, your output should never go to 1. That's the meaning of it. Which means when x1 is 0, it can't be 1. It should be only 0. So this one is not possible. So here you check where and all. When x1 is 0, this is 0. So no issue. Here x1 is 0. Here it is 1. No, it's not possible. 0. First we can see only for x1 with 0. 0. It's 1. Yeah, so 0. This is also not possible. Sorry, I made a small mistake over here. This one is 0, 1. So it's not 0. X1 is 0. It should be 0. It's okay. X1 is 0. It should not be 1. It's so wrong. Then another thing. So come to the second one. When x1 is 1, with respect to this change, it should show the output 1. So this comes under certain conditions. So it can be 0 or else 1. So we can have it now. We can do change when required. So remaining all are possibilities. So only this part and this part can be neglected. So from your required problem, from the given problem, these are the states which are available. Okay, so totally 1, 2, 3, 4, 5 and 6 states are available. Okay, so this is your first initial stable development from the given problem. Now we can go to step 2, that is reduced state table, yeah, state table or whatever you call it. Actually here they are using the word called reduce, but actually we won't reduce here. We will just elaborate a little bit more. Okay, already we have 1, 2, 3, 4, 5, 6 states over here. So first mention it 1, 2, 3, 4, 5 and 6. Then put a line like this. See, this is one way of doing. Suppose if you have any other shortest way also, you can follow. It's up to your wish. This is my own methodology. Not my own methodology. I have spent almost 2, 3, 4 methodologies and I came up with this idea. It is nice. So here also you are going to add this terms only: x1, x2, x1 and z. Okay, so the same old yeah, you're doing this only. Now the point is here what I am going to do. You see, you draw the first for the first state what is the available input and what is the available output. So mention it over there. So 0, sorry, I will use this pen: 0, 0, 0. For second one, 0 1 0. For third one, 0 1 1. Fourth one, 1 0 0. Fifth one, 1 1 0. And sixth one is 1 1 1. So okay, got it. So this is your present state, or the states which are called which are the possible states for the given problem. This is the possible state. Now what I am going to do is, from this state, what are the possibilities? Got it? It's a little bit tricky. So this is the state 0 0. From this state, it can go to 0 1, or else it will go to 1 0, or else it may go to 1 1. These are the remaining three possibilities. Here this one is possible. It may go to this, may go to this, but will it go to this 0 0 1 1? Because there is a 2-bit change. So this condition is called race. So you should avoid this race condition while designing. So the 0 0 will never go to 1 1. That's the important thing you want to remember. With that ideology, apply in all these states. So what I am going to do is, 0 0 means 1 1 not possible, 0 1 1 0 is possible. 0 1 means 1 0 is not possible, 0 0 1 1 is possible. 0 1 means 1 0 is not possible, 0 0 1 1 is possible. 1 0 means 0 1 is not possible, 0 0 1 1 is possible. Likewise 1 1 1 1 once again, 1 1 0 0 is not possible, 0 1 or 1 0 is possible. Likewise 1 1 0 1 1 0 is possible. So each state can go to this kind of different next state. So for this one, this is considered to be present state. These two are considered to be next state. That's the meaning. For this one, this is present state, this is next state. That's how it will work on. Now we want to get the output. So in the output designing, you people are very familiar with one point. When x1 is equal to 0, output is 0. So when x1 is equal to 0, output is 0. When x1 is equal to 0, output is 0. When x1 is equal to 0, output is 0. x1 is equal to 0, output is 0. When x1 is equal to 0, output is 0. When x1 is equal to 0, output is 0. Very simple. Now next point is x1 1, first change. x1 1, any change is there? No change. So 0. 1, any change is there? From 0 to 1 it have changed. A change is there. So 1. 1, any change is there? Of course there is a change, so it is 1. Check over here once again. 1, any change is there? There is no change, so it is 0. Check over here. Any change is there from the state? No. Yes, there's a change, so it is 1. Check over here. Any change is there? Of course, yes, there's a change, so it is once again 1. So you got how we got this reduced state table, but this is not reduced. I said you already. This is a Paka state table. From this table only you can draw your state diagram. Okay. Step 3 is state diagram. Okay. So to design it, actually there's two ways. Either you can draw the states like 1 2 3 4. Here you can draw 6 circles, then you can link it, or step by step, seeing this diagram you can go. Two ways are there. You choose any way required. I'm going to choose the first way. I'm going to step by step, I'm going to move on. Okay. So this first part I'm going to take, and I'm going to draw a circle. In that circle, what I will write is just check it very carefully. 0 0 bar 0. So don't get confused. 0 0 is your so in this first part, this is your present state. So present state value is 0 0. Output is 0. So 0 0 bar 0, and this state is moving to two areas. Am I right? Because this can be changed to 0 1 or else 1 0. So only so put once again a 0 like this. When it is moving to and it is when it is moving to 0 1, what is your output? It's 0. When it is moving to 1 0, what is your output? It's once again 0. Done. So this part is over. Now come to this part 0 1 0 0 1 0 is already there. Now this is the present state. It is moving to 0 0 0 0 0. There is no state like 0 0 0. So you create that diagram. So 0 0 0. Now it is moved to 0 0 0. Then it is sorry, it's already here. No, I forgot. So already 0 0 0 is over here. So you put a direction like this. That's enough. Then 1 1 1. So the next immediate next state is 1 1 1. So I will draw that state, a new state. So 1 1 1. Then draw the diagram like this. Yeah, got it. Done. So this part first, this one over, this one over. Then come to the third one. 0 1 1. 0 1 1. Any state is there? No, nothing. So you draw that 0 1 1. Put a circle like this. 0 1 1. Used to create the state. 1 is moving to 0 0 0. It's there. Okay. So 0 0 0. Then another one is moving to 1 1 1. So this is over here. Okay. Then this part is also over. Now come to this part. 1 0 0 1 0 0. It's over here. It's moving to 0 0 0. So narrow like this. Then 1 1 0. 1 1 0 is not there. So you create the new state. 1 1 0. And this guy is moving over here. Okay, now this part is also over. Now come to 1 1 0. So this state, the newly created state 1 1 0, it is moving to 0 1 1 0 1 1. So it is nearby. So we can draw it like this: 0 1 1. Then 1 0 0 1 0 0. This is this one. So done, over. Then come to the final state 1 1 1. 1 1 1 is here. It is moving to 0 1 1 0 1 1. So a direction like this. Then 1 0 0 1 0 0. Where is 1 0 0? Yeah. So I think you clearly got an idea how to get a state diagram from the reduced state table. Now what you do is now give a name for each and every state available over here. Let this be Z1, Z2, Z3, Z4, Z5 and Z6. So put a box if needed to highlight it. It's your wish. Yeah, okay. So these are the available states. Okay, this is called state assignment. This is the state diagram. And another one thing I want to convey. See, this 0 0 is moving to 0 1 as well as 1 0, which means suppose the same state it shall move itself. No, it is possible, right? So in each and everything, put a loop like this, which means the same state is repeated inside it. That's a loop is like this, which means 0 0 bar represents here, 0 1 bar here, 1 1 1 here, 0 1 1 here, 1 1 1 0 here, 1 0 0 here, and 0 0 0 is over here. So I think you got a very clear idea how to draw the state diagram. Okay, got it. So that's all. This video is over. Now we can the other from this part I will be explaining in the next video. Thank you.